Welcome back, ladies and gentlemen. This is problem 26. We got this stuff up in here, right here. Boys, you might not be able to see the problem because it's a little bit cut off, but it says a very round number that is positive integer that has exactly one non-zero digit. How many integers less than 1 billion are very round numbers? Very, very round. So you can go with the biggest. Well, let's just start with the biggest non-zero or number that has exactly one non-zero digit, which is 900 million. Yeah, right there. So you have 900 million, which has exactly one non-zero, all these are zeros, digit. Now, the other stuff you can do with this is write 90 million. I'm not going to write out the actual number. And then 9 million. And then 900,000. And then 90,000. And then 9,000. And then 900. And then 90. And then 9. And yeah, that's 9. Look at that. That's actually funny. That's 9 possible answers for this problem. But that's not all. That's not all. Now our baby's playing basketball. We can do 8, 7, 6, 5, 4, 3, 2, 1 also. So let's go ahead and erase this.
So you go here.
Now we can do next smallest. 800
So like, was that at the end? Was that at the beginning?
million. Boom. Oh, that's 8 billion. Whoops. Just pretend that's not there. Okay, 8 million. And then we can do 80 million. And then we can do 8 million. And all the way down to 8, which is another 9 possibilities. And then we can go ahead, erase all that. And then we can do a 7. I think you're starting to see the pattern here, boys and ladies. So, you go all the way down to 7 with this, you get 9 more. Then you can do it with 6, then 5, then 4, then 3, then 2, and then 1. Perfect. And then you have 9 different numbers that had 9 different combinations. So what's that? That's 9 times 9. What's that? You guessed it, 81. That's the answer.
Sorry. It's fine. Okay. 7 contestants enter a drawing that begins with 100 balls numbered 1 through 100 in a box. Each contestant randomly selects a ball without replacement. So without replacement is very important because when you replace something, the number of balls in there stays the same. So, without replacement, the 2 contestants who select the balls with the 2 highest numbers will win a cash prize. So, they have to have the 2 highest numbers, and this plays a very big role in this problem. What is the probability that the last contestant will win a cash prize? Express your answer in a common fraction. So, this last contestant, 30, he needs to get something higher than 67, right? Because if he doesn't get something higher than 67, let's just say he won't win. So, we have to get something higher than 67, so we'll take 100, the number of numbers you can pick from, because 1 through 100, you would take that, subtract 67, and you would get 33, right? Now, you cannot use 83. That number has already been picked. You haven't included 67, right? But for 83, you can't use it because it's already been used. So, you have to count out 83. That would mean subtract 1, the number that represents 83, you'd get 32. Let me just clear my screen. So, you would have 32 because you have to subtract 83. Now, if we keep this number at the top instead of down below, we have 32 at the top. This would be the numerator, right? Because you would have it over x. Right? This would be the numerator. It'd be 32 over blank, or x, right? So we're trying to find out what x is. So, out of 100 numbers, how many have been used? Well, you have 83, that's 1, 85, 5, 44, 67, 21, and 30. So 100 minus 6 equals 94. So you would have x equals 94 because out of 100, he can only pick 94 because there are already 6 that are already taken. And we got the first side because, well, how's he win? So if x equals 94, then it would be 32 over 94. So now you would simplify. 32 can be divided by 2. This can be divided by 2. Now, let's break it down. 90 divided by 2 is 45. Now, and you can't forget to divide this 4 by 2. So what would you get? You would get 47. And then 32, you would get 16. So you get 16 47ths, and that is your answer because 47 is prime. You cannot simplify it any further. And this is how you do a problem like this. Thank you, ladies and gentlemen, for listening with your very kind ears. Goodbye.